कहाँ तक चल रहा है दिख रहा है। पकड़ेंगे नहीं आता।
हेलो, सबसे पहले इस इंटरनेशनल सेमिनार में उपस्थित सभी गणमान्य जो हमारे अध्यापकगण हैं, रिसर्च स्कॉलर्स हैं, उनको ढेर सारी शुभकामनाएं और बधाइयाँ। आई वुड लाइक टू थैंक्स द मैनेजिंग कमिटी ऑफ द इंटरनेशनल सेमिनार ऑफ T.P.S कॉलेज पटना। माय पेपर is role of chemistry in material sciences. Material science is often myself, Dr. Rakesh Kumar Ranjan, Assistant Professor, College of Commerce, Department of Chemistry, Patna. Material science is often described as the study of relationship between a material's structure and its properties. Chemistry lies at the heart of this relationship as it enables control over bonding, synthesis and chemical modifications. This paper investigates the role of chemistry in advancing material sciences, illustrating how chemical understanding shapes the development of new materials for industrial, medical and technological applications. Historical perspective में अगर देखें तो the evolution of material science has been deeply intertwined with chemistry from the Bronze Age and Iron Age, which relied on alloy chemistry, to the advent of synthetic polymers in the 20th century. Chemical innovation has consistently driven progress. The discovery of semiconductors, superconductors and nanomaterials further exemplifies the central role of chemistry in revolutionizing material applications. Chemical principles in material sciences: atomic and molecular bonding. Understanding ionic, covalent and metallic bonds is fundamental in determining the mechanical, thermal and electrical properties of materials. In surface chemistry, adsorption, catalysis and surface modification play crucial roles in coatings, sensors and nanostructures. Analytical chemistry, spectroscopic and microscopic techniques are essential for characterizing material composition and structure. Polymer chemistry enables the designs of lightweight, durable and flexible materials used in packaging, construction and aerospace. Nanochemistry governs the synthesis of nanoparticles, nanotubes and quantum dots with unique size dependent properties for electronics, drug delivery and catalysis. Biomaterials, biocompatible materials such as hydrogels, biodegradable polymers and bioceramics rely on chemical designs for medical implants and tissue engineering. In the field of energy materials, as follows: electrochemical principles drive the development of batteries, fuel cells and solar cells. Chemistry provides pathways for designing high-capacity electrodes, solid electrolytes and pre-oxide solar absorbers. Electronic and magnetic materials such as semiconductor chemistry and underpins, transistors, sensors and data storage devices. Chemical doping and defect engineering are key to tuning performances. In modern advancements, green chemistry in material designs reduces environmental impact. Computational chemistry and AI, that is artificial intelligence, accelerate material discovery through modeling hybrid materials such as metal organic frameworks. Exhibit tunable prosperity of gas storage and catalysis. A smart and stimulating responsive materials demonstrate self-healing, safe memory and adaptive functionalities. Challenges and future perspectives. Despite remarkable progress, several challenges remain in harnessing chemistry for material science innovation. Sustainability, many current material depends on scarce resources, energy intensive progresses, non-biodegradable polymers. Chemistry must drive the shift towards recyclable, renewable and eco-friendly alternatives. Laboratory scale synthesis of nanomaterials and biomaterials often faces barriers when moving towards industrial scale production. Green and cost-effective chemical synthesis routes are essential for stability and safety. Future perspectives include circular economy materials, developing polymers and composites designs for reuse and chemical recycling, next generation energy systems, designing novel electrode chemistry, solid state electrolytes and photocatalysis, achieve high efficiency renewable energy solutions, biomimetic and smart materials, creating materials inspired by nature with adaptive self-healing or environmentally responsive properties. Conclusion: chemistry stands as the backbone of material science, providing the fundamental understanding and practical tools to manipulate matter or atomic, molecular and macroscopic levels. From ancient telvage to futuristic nanomaterials, every milestone in material science reflects a chemical breakthrough. The integration of green chemistry, advanced characterization and computational modeling promises a future where materials are not only high performing but also sustainable and socially responsible. As global challenges intensify, the collaboration between chemists and material scientists will remain essential in shaping technology that advance human society. Thank you very much.
Thanks, Ranjan sir. As we are having a limitation of time, so kindly come. I'm requesting you, another participant who is ready to present, kindly come over here. Yes, you will have to just come and then introduce yourself so that I could mark about your presentation. आप लोग में से जो भी अगला वक्ता है, तो प्लीज मैम आइए ना, आप बहुत समय से yes, हाँ, presentation doesn't matter. अच्छा, वो चले गए, उसको बुला दीजिए कंप्यूटर के साथ, अभी जी. Yes, जो जिनका पेपर रीडिंग है as a presentation, kindly come over here. आप लोग में से जिनको जो प्रेजेंटेशन नहीं भी करना चाहते हैं, उस मोड में हैं, तो प्लीज यहाँ पर आइए, अपने आप को इंट्रोड्यूस कीजिए, टॉपिक इंट्रोड्यूस कीजिए, थैंक्स बोल के चले जाइए प्लीज. यस, वेलकम सर.
थैंक यू एवरीबॉडी. सभी को नमस्कार. मैं बहुत बहुत धन्यवाद देता हूँ मैनेजिंग कमेटी के कि मुझे कुछ बोलने का मौका मिला. आई एम थैंकफुल फॉर गिविंग मी अपॉर्चुनिटी टू स्पीक ऑन माई रिसर्च वर्क. माई सेल्फ डॉक्टर राघवेंद्र कुमार, असिस्टेंट प्रोफेसर इन केमिस्ट्री, गया कॉलेज गया, मगर बोल गया. My topic of my talk, role of mutagenic. हमने जो PhD किया था, इथेनॉल प्रोडक्शन पर किया था, जिसका अभी जिस तरह से हम लोग के लाइफ में भोजन, वस्त्र और आवास आवश्यक है, उसी तरह से परिवहन में जो डिफिनिट मात्रा में फ्यूल है, उसको सपोर्टिंग के लिए इथेनॉल का प्रयोग कर सकते हैं हम लोग. उसके साथ साथ बहुत सारे वर्क में भी इथेनॉल का प्रयोग किया जाता है. और इस टॉपिक में है एन इथाइलिन, डाई इथाइलिन, डाई एमीन on bioethanol production. Thank you, sir.
Yes, next one. Please, next participant. I'm requesting kindly come. Yes, come. If you are not in presentation mode, kindly come over here, introduce yourself and your topic as well.
Thank you, ma'am. Thank you, ma'am. Good afternoon to all of you. I am presenting a topic which is already displayed in poster presentation, but now my topic is study of magnetic field effect on rough excuse film lubrication in infinitely wide plates.
So kindly introduce yourself.
My name is Sudhir Kumar from JP University Department of Physics. Research scholar. The performance of hydromagnetic excuse film lubrication is significantly influenced by surface roughness and external magnetic field, especially in roughness and external magnetic, especially in high load bearing system where fluid films sustainability is critical. This study presents a theoretical analysis of the combined effects of transverse magnetic effect and longitudinal surface roughness on the behavior of excuse film lubrication between infinitely wide parallel plates. Thank you. Thank you so much.
Thanks, Sudhir Kumar. Can you tell me you are from which institute? आप कौन से इंस्टीट्यूट से हैं? आपका नेम इसमें नहीं है इसलिए बेटा. JP. Okay, thanks.
My name is Manish Kumar. I am from Bihar University. My topic is related to physics. Topic is study of RF MEMS technology for higher isolation and broadband application. इसमें कैसे आइसोलेशन को ब्रॉड करना है कि वो आने वाले सैटेलाइट्स में ज़्यादा से ज़्यादा उसको और ज़्यादा विकसित किया जा सके और हाई आइसोलेशन के थ्रू एनर्जी जो भी सिग्नल एनर्जी लॉस होता है उसको कम से कम किया जा सके। इस टॉपिक में मेरे जो गाइड हैं वो हैं डॉक्टर राजेंद्र प्रसाद, BRBU, LS कॉलेज, बिहार यूनिवर्सिटी, मुजफ्फरपुर। थैंक यू।
Yes, next one. Next participant, please come over here. Come to the left and desk and deliver your lecture presentation or kindly introduce yourself with your topic.
Good afternoon, all of you. Myself, Nishant Kumar, University Department of Physics, JP University, Chhapra, Saran, Bihar. My topic is metallic particle in cavity nano antenna as a prototype for jet enhancement of second harmonic and directional tunable radiation. Thank you.
Yes, next participant. Next participant, please come. Next participant. Yes.
My name is Abdullah, research scholar, JP University. is a behavior and morphological changes induced in fresh water, Weisselia reticulata.
सर काइंडली इंट्रोड्यूस। आप अपना परिचय दीजिए और अपना यूनिवर्सिटी का नाम बताइए। Yes, welcome.
My name is Raja Babu, research scholar from Tripura. My topic is development of concept radiation detection, जैसा कि जो इलेक्ट्रॉनिक्स से इसके थ्रू से हम कॉस्मिक एनर्जी को डिटेक्ट कर सकते हैं। इसकी इलेक्ट्रॉनिक्स के थ्रू हम लोग स्टडी कर रहे हैं यूनिवर्सिटी में। तो हमें जो डेटा मिला है उसको टेलीस्कोप में कुछ डाला हुआ है, तो आप देख सकते हैं।
Yes, next one, please come.
Dear friend, all of you,
जी आपका नाम?
विवेकानंद कुमार, रिसर्च स्कॉलर, डिपार्टमेंट ऑफ फिजिक्स, BN मंडल विश्वविद्यालय राहुल नगर मधेपुरा। My topic is exciton acoustic phonon coupling in single quantum gallium arsenide quantum dot.
Thanks. Next one. Next participant, please come.
Hello, my name is Lahansu Rajak, Department of Chemistry, RRS College Mokama. My topic is biotechnological role of 4-chlorofluorochloroformyl coumarin in improving citric acid yield from Aspergillus NCIM 922. Thank you.
Yes, next participant. Sir, you are a faculty member, no? Aren't you? Faculty member. Please.
My name is Vishnu Kumar. My guy's name is Dr. Suresh Kumar Pandey. I am a research scholar. My topic is low power optical interconnect in data center using machine learning optimization. JP University.
आपका इंस्टीट्यूट कॉलेज?
JP University छपरा.
ओके, नेक्स्ट वन.
My name is T.P.S. Kumar, Department of Physics, Patna University, Patna.
Kindly introduce yourself, your name is?
Neeraj Kumar.
Neeraj. Okay, thanks.
My topic on study on the structural, magnetic and optoelectric properties of manganese dope gerano. Thank you.
आपका ये यूनिवर्सिटी क्या है?
Good afternoon to all of you. My name is Paramjit Kumar Singh, JP University Chhapra. My topic name is theoretical study of charge transfer thin film with rough interface. Thank you.
From which university? Thanks. Next participant, please come over here. Ma'am, have you given your slides? Okay, whenever you wish to come.
Good evening, all of you. My name is Harendra Kumar. I am research scholar of Patliputra University. My research topic is synthesis and characterization of some novel oxygen-based complex with a different metal ion.
GPU Chhapra.
Patliputra University. synthesis and characterization.
I'll request ma'am to come over here for her presentation.
Good afternoon, all of you. I am Sandeep Kumar, research scholar at T.P.S. University, Patna. My topic is optimal using charging smart grid to improve development. Thank you.
Yes, now ma'am will present. Okay.
Good afternoon. My name is Pramanda Kumar Singh from T.P.S. University, Chhapra. My topic is theoretical modeling for optical solution in dynamic in area of nonlinear fibers.
आप रिसर्च स्कॉलर हैं? ओके, अब तक अभी कोई नहीं आएंगे, अभी मैम जो है वो प्रेजेंट करेंगी पेपर.
Good afternoon, everyone. I am Dr. Sangeeta Indra. I am from College Hilsa Nalanda, Department of Chemistry. So my topic is design of solvent absorption approach for capturing volatile organic compounds. So nowadays environmental pollution is a global issue, and some gaseous pollutants which are prevalent in our atmosphere are carbon monoxide, sulfur dioxide, NOx and VOC. So we are interested in VOC, volatile organic compounds, and here the volatility is the main problem. So what is volatile compounds? Which have high vapor pressure and low boiling points. So as vapor pressure is high, so they can easily evaporate and come to the air. Here some commonly occurring VOCs are like this: aldehyde, acetone, benzene and toluene. So what are the impacts of VOCs? They mainly cause air pollution, smoke formation and abnormal change in local atmospheric temperature. And VOC have major health effects also. Short-term effects are shortness of breath, confusion, convulsion, etc. And long-term exposure to VOCs can lead to several issues like lung infection, asthma, and even cancer. And most interestingly, the sources of VOCs are mostly anthropogenic, means man-made. So what are the outdoor sources of VOC? Industrial emissions, vehicle exhaust, fuel burning, and indoor sources are like use of paper, sprays, paints, etc. So there are different conventional technologies are available like thermal oxidizer, catalytic reactors, biofiltration system, but none of them are sufficient enough to combat the situation, and sometimes they involve high operational costs and secondary pollution concerns. So what would be the alternative way? So designer solvents like RTI, room temperature ionic liquids and debutating systems are already known to be the storing agent for gaseous compounds like hydrogen, carbon dioxide, etc. So we wanted to check whether these designer solvents can capture VOC as well. So what are designer solvents? Designer solvents are those which have high solubilizing power and tunable polarity. Why their solubilizing power is high? As both the polar and apolar moieties are present, so they can solubilize a wide range of compounds, and you can also tune the polarity of the designer solvent by changing the functional group or substituent groups. Here we have used classical molecular dynamic simulation method, and we wanted to build a connection between experiment and simulation from molecular perspective. Now what we have done, we wanted to create the vapor liquid equilibrium. For that, what we have done, we have elongated the z-axis of the simulation box. There are two simulation snapshots, one at time 0 and another is at time 40 nanoseconds. So what you can see that at the beginning of the simulation, the VOC, the red colored symbols are VOC. VOCs are distributed all over the solvent, but after some time they are aggregated at the intersection region. To quantify this, we have calculated the Z density distribution And from the lower panel plot, you can see the Z densities of VOCs are maximum at the interfacial region. The shaded area represents the interfacial region. Next, what we wanted to change is that what is the interaction energy or free energy of the VOC molecule when it goes from vapor to liquid state. So you can see that there is a minima and the distance is corresponding to the interfacial region. So, and this is also visible for RTIL as well. So both the RTIL and DES VOCs are stabilized at the interfacial region. But the interesting thing is that the difference in energy. In case of DES, the stabilization energy is in the order of 30 kilojoule per mole, whereas in RTIL the interaction energy, the minimum energy order is 10 kilojoule per mole. So, from where the stabilization is coming, this is due to the preferential orientation of the VOC molecule at the interfacial region, and this has been shown by the 2D probability density distribution function. Hence, we can conclude that both the designer solvents are found to have potential to absorb VOCs effectively, but DES wins the race. Now, at the end, I want to acknowledge DST, Women Scientist Day for funding, IIT Patna for research facilities, Professor Gajendra Prasad Gadkar, my principal, Dr. Ranga Subramanian, my former mentor, Dr. Snehashita Chakraborty, my collaborator, and all the colleagues and staffs of my college, SU College. Thank you so much for attention.
It was very nice, excellent presentation, ma'am, Sandeepa ma'am. Now, one sir was there. Please kindly come over here, introduce yourself, and do your presentation. Your presentation slides are ready. I do the. Sir, have this hand mic also.
Good afternoon, everyone. I am Dr. Samrat Sarkar. I am Assistant Professor of Physics at SU College, Hilsa. My topic is hierarchical nickel cobalt NDH, nitrogen doped carbon holospheres, and it is acting as a novel electrode material for asymmetric supercapacitors. I did my PhD from Jadavpur University and my postdoc from Chennai University, and recently I have joined SU College. So when we are talking about supercapacitors, so first we will introduce about supercapacitors in a brief way. We know that the energy storage devices, there are many types of energy storage devices such as the batteries, fuel cells. Then why supercapacitors? So supercapacitors are a different class of energy storage devices. They have certain advantages and certain disadvantages also. So supercapacitors are mainly of two types. They are EDLC, that is electric double layer capacitors, and pseudo capacitors. And both ETLC and pseudocapacitors have their own merits and demerits, but combining the two can be advantageous, and in our work we have approach to the hybrid capacitors. Now this is the dragon plot or the energy power density plot of various energy storage devices. And the supercapacitors, especially the hybrid supercapacitors, they are sitting at the sweet spot of good energy as well as power density. Now these are the advantages. These are the advantages. These are the advantages and the disadvantages of supercapacitors. The main advantages are the high power density and safety compared to the batteries. And there are diverse applications of supercapacitors. So most of us know about the diverse application, but we will just go directly to our work. Now, the nickel cobalt LDH, layered double hydroxide, and the end-doped carbon spheres were synthesized by a two-step method. First is the synthesis of PNMA, that is poly-N-methyl anemone. This was done by the low temperature polymerization of N-methyl anemone. And then the PNMA that was produced, that was used in solution co-deposition method with nickel and cobalt sources to get a layer of layered double hydroxide over the PNMA. Now the PNMA is a polymer and it is covered with layered double hydroxide LDH. Now when it was mildly annealed at 300 degrees centigrade 2 hours, then we get the composite. The polymer was converted due to carbonization into nitrogen doped carbon, and it was covered with a thin layer of LDH. Now this slide, I don't know, it is not working here, it is just working in. This was the just characterization. There it was showing the XRD, the FSM and the bead surface area. But it is okay. These are the same images and we can see the carbon sphere. The formed carbon sphere, it is hollow. It can be seen from the same image. When one carbon sphere is above the others, we can see it is a hollow carbon and there are LDH layers covering the hollow carbon. It is more, it can be seen more clearly in the FSM image, but the FSM image was in the previous page. And these are the 3 electrode study. That is the study we have done in electrochemical workstation. These are the CV analysis, and the CV analysis and the charge discharge shows good electrochemical behavior. From the charge discharge analysis, we have calculated the specific capacitance, which is about 1350 farad per gram. So it shows a very high specific capacitance at 1 ampere per gram, and also good rate capability for this electrode material. Now, such a high specific capacitance can be attributed to the pseudo-capacitive contribution of the LDH, the interfacial capacitance of the carbon sphere. But we can also consider a third contribution, that is the quantum capacitance. And for that, DFT analysis was done for our material. We took simple models, the supercells. This is the nitrogen doped carbon. So this is the carbon lattice and one nitrogen atom was inserted and the density of states were calculated. And this is the LDH, nickel cobalt layered double hydroxide. And the third one was the composite, a layer of the NDC, nitrogen doped carbon, and LDH. And we see here that the local density of state near the Fermi level is very high, and that is the prerequisite for quantum capacitance. Now we also calculated the quantum capacitance here from the density of states. We know that the residual quantum capacitance for a small system is square into density of states. That is the quantum capacitance per unit area. Now, if we integrate for all the surface, then we get the quantum capacitance per unit area of the whole material. And that was exactly done, and considering the thermal bottling function, because we have calculated by DFT at 300 Kelvin, that is the room temperature, and so the FT thermal bottling function was also introduced, and we have got the value of quantum capacitance. It is about 974 microfarad per centimeter square for the composite material, and that is quite high, and that is a major contributor to the high capacitance of the electrode material. And since we have got very good result, so we also thought about making a device out of this. So now the two electrode or the device study of the material, we just used our material, that is the nitrogen doped carbon NDH as the positive electrode and activated carbon as the negative electrode, and these two systems were just assembled together in a gel electrolyte, and we got the device. And these are the CV and the GCT of the device, and this we got 185 millifarad per centimeter square. That is a very good specific capacitance for a device, and also the long cycle capability of the device is also very good, and the actual picture of the device is shown here. So this is the assembly. The positive electrode in notch is given, and these are the three electrode studies, solar electrodes. These are the device, and this is the demonstration by lighting up the lamp. And our device also show very good energy density of nearly 65 watt-hour per kg and a power density of 2.7 kilowatt per kg. And this is just at the upper range of the energy and power densities that are reported in the literature. And also the stability, just we have shown here, the stability is very good. After 20,000 cycles, it retains about 90% of the specific capacitance. Now, first of all, I thank all my collaborators, and also I express my gratitude to the PhD supervisors, my family, my wife, and also the faculties of SU College. And I express my deepest gratitude to T.P.S College, Patna University, and the organizers of the conference. And this is our research team. This work is ongoing, and the most of the work was done in Jadavpur University in Professor Kalyan Kumar Chattopadhyay's lab. Thank you.
And T.P. Chattopadhyay is big boss. He is also my friend, good friend. Okay. Since you are doing this today, see, thermal stability of the surface.
Yes. So we have already done the TGA. So the TGA was done at about 350 to 400 degrees centigrade. The LDH layer becomes very thin. Now when we cross the 350 degree, so the LDH almost vanishes, and we get only the nitrogen doped carbon. We have not shown the TGA, the XPS, because I thought that I will not get so much time. but the TG analysis, the zeta potential, and also the XPS, in which we get the pyronic and the pyridinic and the graphitic carbon that we have not shown here, but it is stable up to 3 degrees. Thanks.
Thanks, Dr. Sharma.
5 minutes. Thank you.
Hello, good afternoon everyone. Actually, I was to say good morning, but good morning is converted into good afternoon, and time is also running short. It is already 2 minutes to go before. Just open the slides. I will cut my entire long story into very short. So the title of my talk is the iodine captured by T.P.S based porous organic polymer for environmental remediation. So here 2 words are there in environmental remediation. So 2 words are there in environmental remediation. So why environmental remediation nowadays catching much attraction? Because as we need there very often the acid rain and drastic environmental condition as well as unwanted environmental issue because of this environmental remediation. So it indicates the environmental reaches in the alarming condition. So in order to address this issue, we have to much focus on the environmental concern. By looking at the patent literature study, we have seen that around 30% of the worldwide electricity is satisfied by the nuclear power plants. But nuclear power plants is not that much easy to manage. There are some shortcomings as well as good aspects are there associated with nuclear power plants. So what are the pros and cons associated with nuclear power plants? So these are the pros and cons associated with nuclear power plants. It helps to reduce the dependency of fossil fuels as well as oil gas user. However, there are some shortcomings associated with it. What are these shortcomings? These shortcomings are the handling of their radioactive system, safe processing, as well as long storage and their disposal of radioactive waste. Their disposal is also one of the important parameter factor. It is not a simple dump you can just dump somewhere. It has a radioactivity content. If you are dumping somewhere like that without the treatment, so it may have the harmful effect. And among these, the usually waste contain the carbon-14, iodine-129 and iodine-131. Among these waste, the iodine-129 is the most harmful. Someone can think why only this particular species is most harmful and most problematic species. The reason behind is that its half-life is very high, around the 16 million years. As a result, it stays longer time in the environment and creates so many health disorders and risks. So in order to address this issue, several kinds of adsorbent reported in the literature like carbon, ore, zeolite. Among these species, one of the components is the T.P.S. T.P.S is nothing but a bicyclo 2-octane ore which has a 3 phenyl ring in the periphery. So one general question comes in the mind, why the T.P.S? What is the more inherent feature in this molecule so it is getting this much attraction? The reason behind is that it has a 3D structure, it has an aromatic background. We can see here the 3 phenyl ring is associated in its permeability and the fatigue efficiency. And all these features imparts is thermal stability, organolepticity as well as microporosity. All these features makes it a potential candidate for the iodine uptake. There are some familiar examples of T.P.S is reported in the literature. You can see here the 1,4-disubstituted as well as 2,6-disubstituted. These species mainly fabricate the linear kind of polymer. However, apart from these two prominent species also reported in the literature very frequently, which mainly gives the 3D polymer kind of network. By having this much information in my hand, and further we have investigator literature. By investigator literature, we come to know about that there are several 3D polymer reported in the literature in which author has claimed the iodine uptake capacity from 105 to 421 weight percentage. So this is our motivation part. So how we can make a molecule which can also have the iodine uptake capacity nearby this or more than that. For that, what we have done, we have synthesized a molecule which contains T.P.S as a core as well as protease in this core. We have synthesized this molecule using 2,640 primary T.P.S using this reaction condition which gave this polymer. And this polymer is substantial around 70% and having light brown color. After that, its characterization part is completed by the 13 CNMR, IR spectra as well as photoexactive pattern. If we look into the IR spectra of this compound, where we can see in the starting material of precursor, the NH2 group or the triamino compound is present. However, that group will disappear in the polymer, which clearly indicates the formation of successful formation of the compound. When our shifted our attention is photoexactive pattern, we can see the broad spectrum of this compound shows the amorphous nature of the compound. Having this much information in mind after this characterization as well as successful formation of the compound, we have shifted our attention to investigate its iodine uptake or as well as iodine release. Because both things should be there, and uptake as well as release. Because sometimes situation demands is there. If forward gear, the such a situation demands, the backward gear is also needed. It should not always be forward gear. The situation demands how you have to proceed in the particular situation. So we have investigated this iodine uptake as well as iodine release experiment. So in order to do that, what we have seen in the spectra, in the first 12 hours of the experiment, it has around 462 weight percentage of the compound. However, when we further investigate, further proceed the experiment, we have seen that there is no marginal increase in the compound. It indicates that it has got maximum capacity of 462 around the 35 or 36 time hour. When we further investigated its iodine release capacity, we have observed 86% of the iodine release capacity in the solid state. One of the reviewer asked about in the solid state, what about situation in the liquid state? So for that, what we have done, we have immersed this compound in the solution state. Using this reaction condition, we have slowly observed what the reaction of this compound is changing from this color to this color. And eventually we have got the pale brown crystalline compound again, and this way it shows the both kind of things, absorption as well as release. So these compounds have good absorption as well as release. Now in our mind came what strategy should be adopted to make an ideal candidate for the absorption. What should be done in the polymer or how it should be tuned so that it can have maximum capacity. So first, for that what we have to do, we have done the what should be incorporated in the compound so that it should have a large uptake capacity. It should have large uptake. So for what we have done, it should have high surface area. This polymer should have 3D polymer. Second, it should have a microporous material. So the pores should be there so that it has an absorption tendency. Third, so absorption at a large amount of gas at a low pressure. Pressure should be not too much high. It should not be in very harassed condition. In the normal condition, it should propagate or it should have the absorption tendency. Apart from that, what other conditioning environment or SSL environment we should incorporate so that it has absorption tendency at room temperature or not in very high conditions, or it should have around 60 or 70 degrees. Because very harassed condition, you have to maintain so much restriction, long reaction hours. So for that one, it should have 3D polymer network, presence of electron rich center. Just like a nitrogen, the electron lone pair is there, they can interact with the vacant orbital of the iodine. Further, interaction of the iodine with the polymer weapon, and it happens by the charge transfer phenomenon. All these phenomena make the ideal candidate for the iodine uptake. And this is the graphical aspect of the entire web in one slide. And this is the some representative references from the current scenario. Thank you for your kind attention.
Thanks, Saurabh sir, for excellent presentation. I hope.
What? In which phase? Both solid and liquid phase. In methanol. Methanol, why is you are asking if this type of methanol has low boiling point? If it is after releasing the compound, solvent evaporation is also a big thing. If you are using a high boiling solvent like DMS or DFL, removing the solvent is also an issue.
Now I request Palati sir to kindly direct me for binding of the session.
Okay, you can bind this technical session. Now we'll go forward for the next session.
Next session.
Yeah. All right.
It's nice. A gratitude is ample to Professor Chitranjan Sinha sir for chairing the session. And thanks to all of you all the participants and esteemed teachers, professors, and special thanks. In fact, a big bouquet of thanks goes to our Professor Chitranjan sir. Thanks a lot, sir. Thanks. And thanks, Paladi sir, for organizing this international seminar on recent advancement in basic applied and material sciences. And in economic, we say Radams 2025.
Okay, good afternoon everyone. Before valedictory session, the last technical session of two days international seminar Ravans 2025. Now we have our chairperson, our respected Professor T.P.S ma'am with us from AIN College Patna, who will chair this session and formally will introduce with the speakers. Welcome, ma'am.
Thank you, Dr. Paladi, and congratulations for conducting this conference. This is the last technical session of this conference, and the first speaker I would like to invite Dr. Subhadeep Paladi. And the brief introduction of Dr. Subhadeep Paladi is that he is currently working as an assistant professor in the Department of Electrical Engineering at Indian Institute of Technology, Indore since April 2023. Before joining IIT Indore, he was with the University of Glasgow, UK as a postdoctoral research associate in the Department of Electronic and Electrical Engineering. He received his PhD degree in Electrical Engineering from IIT Kharagpur in 2021. He is a recipient of several prestigious awards, including POSOCO Power System Award for his research contribution in the area of power network protection in the presence of converter interfaced renewable energy sources. His current research interests include power system protection and monitoring, machine learning and digital twin applications in power system, and operational resilience of converter-dominated power system. Dr. Paladi is a senior member of IEEE. Apart from the research, Dr. Paladi is also associated with several collaborative consultancy projects for vetting the electrical designs with proper component selection and translating the new protection technology into product. So, Dr. Subhadeep Paladi, now the session is yours. Kindly come to the dais and for your presentation, and he will be presenting on the topic that is recent advancement in basic applied and material sciences.
Good evening, everyone. Thanks, ma'am, for introducing me to you. So, before starting the presentation, probably after the introduction of me, some of you or most of you may be thinking that how to spend almost 1 hour, next 1 hour, because you are coming from different areas. At least not from electrical engineering. But believe me, I hope you will take every point of my presentation. So I have prior information that whom I am going to present, and accordingly I have oriented my presentation. So I am not going to discuss any core research works of my research group. So actually, to sell a product, you should have the idea that what is the demand in the market. Similarly, if you want to establish yourself in your domain, you need to know that what is the trending focus of the society as well as the government, and you should align your research into the similar domain. After coming here, I just attended the last talk. So at the end, you are citing some examples of Madan Mohan Malviya regarding the establishment of BHU. So that I remember one story. So I just want to give some things for that. So do you know that who funded the establishment of BHU? Something was hidden and very less story are here. Land and money. It was came from Nizam, from Hyderabad. So now you think this is Hindu University and it is sponsored by Nizam. How it was possible? So I am not going in the detailed story. Because of some motivation, he went to Nizam asking some contribution to establish the Hindu University. Then he replied, I cannot give any money. I can give only my suit for such initiative. Suddenly, he responded, please give your suit. He came out from the palace and then started Nilam of this suit. That Nizam suit, who will buy at this rupees? Started marketing. Then that news came to Nizam. Then he came to him, please stop this, I will give the money and land whatever you need. So, like that you should know that how you can contribute in interdisciplinary domain. That is the thing. Now, yeah. How many lectures you have covered in this course so far? I will not give one way presentation. I don't like that. I want interest. So, you are not responding. Then, this is the last session. That means you are almost tired. Yeah. Then, it is the suitable session for me. Why? Because I am also tired. I started my day in the early morning at 3 o'clock because no direct flight was there from Indore to Patna. So, you know, the good friendship lies between two persons at what time? Yeah, you are guessing something correct thing, but you are not responding because you are talking. You are in now Bihar, where alcohol is banned. Yeah, when the two persons are drunk. Similarly, I am also tired. You are also tired. So I think good discussion will happen. So back to the topic. So whenever it will run, it's fine. I can talk without presentation also. So this is renewable irrigation in India. This is one of the prime objective of society as well as Indian government. So in this presentation, first we talk about the necessity. Parties, either we are talking about suddenly renewable irrigation. Of course, the course is on basic, applied and material, advanced material science like that. So engineering is comes under applied science. So this is the application where anyone can apply their knowledge. So we'll see the term requirement of renewable irrigation, then what are the plans, what is the status, and then what are the challenges we are facing. And after that, we'll see what are the solution. So let's start. Yeah, heads on. So energy transition. So why I am suddenly going to this? Because of this blank side. So actually flow is the characteristics of river, similarly transition is the characteristics of light. When you will experience the same thing, then you will feel bored and the mental issues will come. So you need to go through the transitions. Similarly, we have noticed several transitions in different sectors. Like in the electricity sector, earlier it was coal-based plant, maybe in the last century most of that was coal-based plant. Now we are talking about renewable energy sources. It is everywhere. Transportation, communication. In communication also, you may think how the communication used to happen. Earlier, something like pigeon was the medium of communication. Now we cannot think of this. Transportation, I don't know, you can see bullock carts or not right now. So this is the transition in transportation. Like that every sector is going through the transition period. So I am not going to elaborate on every section. So I am picking the energy sector. Here you can see the energy sector transition. I am not talking about the centuries now. Only the decade 2015 and 2025. In 2015, you can see that most of the power generation was shared by fossil fuel based plant, that is the thermal plant, and almost 81%. And in 2025, it has reduced to less than 50%. So how the transition is going? And of course, who is replacing? That is the renewable energy sources. And it is not in India, it is throughout the world. So you can see the advancement in the China, Germany, Brazil. The rate is much higher compared to India. Now if you see the jump, from 2015 up to 2024, it is there from 14% to 32% journey. We have already seen that what is the status at 2025. It is almost 50% going to reach. Now, this is a good sign. Now comes the bad side. Growth in the renewable energy sources, that means something is reducing. So what is reducing? That is the fossil fuel based generation. So this is the data state-wise in India, how the thermal power plant or fossil fuel based power plants are getting retired. You may think the misery of the workers who are working in the thermal plants which are retired. So no transition comes smoothly. Suppose you are starting your dinner cooking. You have some ingredients for cooking. You thought that okay, we'll taste something new today, and you started cooking. And when you started eating, taste was very bad. That time you will think, why I have thought of this making new recipe. I have to sleep after eating this kind of food. Similarly, here also we are thinking, why we are creating so much misery for the workers who are there in the thermal power plant. Okay, of course, definitely some reason was there. That's why we are doing. So we'll see the needs. More or less, we know about the issue of global warming. I'm not discussing in detail because that time is short. So just a review from the industry evaluation. There, since there, almost 1.5 degrees centigrade temperature have been increased for Earth's surface temperature, and you can see the temperature change over the 50 years like that. So global warming is the main issue. Now, if temperature is increasing, suppose temperature is increasing, why to worry? We have AC. We can decrease the temperature setting and we can live happily. No need to worry about temperature rise. AC cannot solve all the issues. Which are those issues? Suppose this fire season. Yeah, the video is not playing. Okay. Fine. So actually the wildfires are increasing. Rate of wildfires are increasing. Some examples I have cited here. So this was a nice video. I cannot play here, why. So this was the Australian wildfire in 2019. So you cannot control, and this rate of fire seasons are increasing day by day because of this global warming. Similar other issues are there like floods, cyclones. We know that in India also we are facing every year new cyclones with peculiar names. So I have cited here 3 cyclones recently we have experienced. One is from in India. Similarly, we are facing floods also. We know that the flood scenario in Uttarakhand or Jammu Kashmir of the floods are there. All are result from global warming. Not only this, global warming is changing the biodiversity. So plants and animals are migrating to their suitable situation. Here we can see some trees like rhododendrons or oak. Those generally grows in the cool weather near the hilly areas. But due to the rise in temperature, the tree lines are going the upper side of the trees. Similarly, we can see the effect in apple and maize beds, grapevines, they are migrating. Wherever we used to get those things, we are not getting. It is migrating to some other places. Similar effect we can see in the animals also, like polar bears, some peculiar animals, like some special butterflies. Those are not visible where it was available earlier. Due to the temperature rise, you can suppose, I think last year, this thing happened, then more than 1300 pilgrims died in Makkah. Why? Because the temperature exceeded above 50 degrees centigrade. Similar thing happening in many places. You can also experience the change in monsoon, say the heavy rain. What is the season? Can we expect such heavy rains in this time? But it is happening. So such change in the climate has a great impact on the agriculture also. We cannot think that when this thing is going to happen. Even the society also, we are suppose planning some party in the winter, thinking that no rain will happen, but rain is happening, disrupting the party. So everywhere such effects are coming. So now these are the consequences. Then what are the reasons behind it? So we need to find out. Generally, the global warming is due to the fossil fuels. Those are emitting the greenhouse gases. From where it is coming? Mainly from power sectors. Also from the vehicles or industries also. There are some other reasons also, like destruction of forest, animal farming, and use of pesticides in the agriculture. So, main culprit is the coal-fired power plants, which is contributing almost 36% of the greenhouse gas emission. So now we have identified the main culprit. So we need to replace it. Who will replace? We have our great Prime Minister. So Modi ji announced in 2021 in Glasgow that we have Panchamrit. This is not about ghee, milk, not like that. Panchamrit in climate action. 5 nectar plants. Which are those? First is that we have to make the renewable energy sources to 500 megawatt by 2020. Then second was that 50% of the total energy should be made by renewable energy sources. Then I have written, I am not reading thoroughly, just it was regarding the reduction of carbon emission and the renewable energy integration status. And finally, final goal was that by 2070, we should reach fully decarbonized system. No thermal power plant or nothing will be there, only renewable will be there. His job was done. Now task is on us. How to complete this commitment. Yeah. This was the need of the hour. Why? You can see from here, fully green areas are fully decarbonized. So many countries have already achieved the decarbonization. So if you are going to be a representative in the world scenario, then you have to commit such. So already some countries, like whatever I have mentioned here, more than that also it is there. So, so those countries have already reached their 100% target of renewable energy sources. What about the status in India? Yes, we have also reached near 50%. So we are progressing well and following the targets. So why we are not meeting the 100% now only? We don't have money. Which is not the case. We don't have workers to install the solar plants or wind plants throughout the world immediately. India is one of the most populated countries. Everyone will, wherever someone is facing some issues, yeah, can we help you? So there is no limitations on this point of view. Then why we are not achieving the 100% now only? So we are facing some issues. Some of the issues I can show here. You may have experienced this thing. Then somebody will tell, yeah, we are facing this regularly without renewable also. Then what is the new? Suppose earlier people used to take the drinking water from river, then started getting stomach issues, diseases like diarrhea. Now, that issue is solved. They are using purifiers to get the proper water. But still, they are getting the stomach issues. Why? Because they have started the frequency of taking food from the outside restaurants. So maybe the reasons are changing, but the effect will be the same. This was due to some different issues. That issue is solved. Now the renewables are creating the issues. Something like we can get sudden outage. We'll discuss why it is happening due to the renewable irrigation. This is the burning of induction motors. Sometimes motors are getting stalled, moving very slowly. Sometimes motors are moving very fast and getting burned like this. These issues are increasing due to the renewable irrigation. Some issues also there which have not presented through pictures. Something like, of course, I have mentioned that job issues, that those persons who are working in the thermal power plant, it is very difficult for them to adapt with the new technology. They are not recruiting in the renewable plants as the work plants because they don't have that skill. Some issues are coming regarding the biodiversity also. Suppose winds are changing the wind patterns and creating the noise pollution for the birds and those things. Reflection from solar panels are creating the issues for the birds. Those we know. Apart from that, we can get some unpredictable electricity bills also. Why? We'll discuss. So now we are facing these issues. So of course we want the solution, but how to solve? First we need to find out the reasons, then only we can solve. So first the reason is that variability in intermittency. You can see that a solar plant, wind plant, covers a very large area. Suppose some cloud is passing over the solar plant. So some panels will not generate the electricity, some panels will generate the electricity. So you cannot predict that how much generation you are going to get from this particular solar plant. Similarly for wind plant also. At daytime, solar is generating the power. Night time suddenly it is zero. So this is variability and intermittency issues are there, which are generating the fluctuation in the voltage level at power level. That's why that flickering issue is going to increase if we are relying fully on the renewable sources. You can see the second image where in the northern sea the wind plants are there. So generally the offshore wind farms are installed in the seas. So large distance the power need to travel. So we are facing a lot of losses, transmission losses. This is the inertia. So I think there are science background people. So everyone knows that rotational inertia concept at least. Suppose you are cycling and stop paddling. Then also cycle will move for some distance because of the rotational inertia. Similarly, earlier the thermal power plants or hydro plants used to generate the power through synchronous generators, which have large rotating part. So rotating part will store the kinetic energy. Whenever some emergency situation will happen, some deficit is there, that kinetic energy will supply and manage the situation. But now, solar plants, wind plants, everything is getting connected through inverters, which do not have any rotating part. So then, no kinetic energy. So no one is there to handle the emergency situation. So grid is very vulnerable. one small disturbance can lead to instability of the system. I have cited one example here. You all know what is the picture here. Vishnu on the arrow bed. Can you respond that how many days he was in the arrow bed? Yes? No. It was 58 night, total 59 days. So many arrows were stuck in his body, then also he lived for 59 days. What is the picture? This is the death of Lord Krishna. One single arrow struck in the foot and he died. How? This is pathology, no science. Okay?
So it is also having comic theory behind it.
Anything. So I am not here to explain everything. I am just delivering my message. Let you think whatever. So one person is living 58 days or 59 days with so much arrows, and one person with single arrow stuck in his foot and died. Because that was the only vulnerable point of Lord Sri Krishna. Similarly, earlier, yes, when it was thermal power plant based, synchronous based generation, lot of disturbances used to happen, but it used to get stabilized because of the stored kinetic energy. But now, system is too much getting vulnerable with the inverters. That is small disturbance may collapse the system. So we need to think on this class. There are some other operational issues. This is a load car. What is load car? So this is the daily demand. Starting from 12 a.m. midnight when the day is starting. So that time sleeping time we are consuming very less demand. Then day is starting around 6 a.m. or 7 a.m. Then we have the demand. Original demand. We are facing, we are going to the work, and then at the evening we are coming back to home and taking work, using the heaters or started cooking. Then suddenly load is increasing. This is the common load pattern in India. And again, it is going for the sleeping time reduction. Now, renewables are coming to share the demand. Suppose you have a large solar plant. Now, solar plant is saying to thermal plant, you don't have to take pressure. I will share your load. So, he is sharing. So, some portion he is sharing. That's why the demand of thermal power plant is getting down here. But whenever the evening time, sunlight is gone, no one is there, all pressure is on thermal plant. It is very difficult to adapt of so much change. If you are taking, some of you, most of you are teachers also. So suppose you are taking regularly 3 subjects, then it's fine, you can manage 4 subjects easily. But suppose you have suddenly a large number of faculties, so you are taking only 1 subject, and due to some issues, few faculties left, and then again you are being told that okay, take 2 subjects. It is difficult to adapt because you will lose the habit. One thermal plant takes almost 12 hours to start. So immediately whenever we need that, okay, we need this much large demand, we cannot switch on the button and start the thermal plant. It is not possible. This is the main operational issue with the renewable sources. Then again we have to think that okay, which renewable plant is operating when the wind plant is generating, when the solar plant is generating. So much management issues are coming. And it is difficult to forecast also that when we will have the rain, when we will have the high wind, those things very difficult. So with so much difficulties, no one is going to prefer renewable energy sources in education. Still we need then what to do? You know the starting of Geo. How many days you have availed the free service from Geo? You start, maybe you took the Geo SIM because of the free service. Similarly, government is imposing that you take renewables will give this much facilities. Government has initiated so many missions on the renewable, but everything will not be forever like Geo SIM. So someday those will not be available. Then how these things will be adapted? So we have to think of this perspective regarding policies. Now, how to solve such issues? I am not discussing much on this thing. So how to solve? One of the solution is that use hybrid system. Suppose sometimes wind will generate at night time, generate high wind we can experience. That time wind will generate. At daytime when low wind will be there, solar will come into play. Use some storage like that hybrid system if you can make with proper forecasting, then you can solve some of the issues. Now, as renewable energy sources are not available throughout, so we need storage, but those are too much expensive. We need to find the alternative solutions. Yeah, hydrogen is coming as one of the solutions. Instead of consumer term, we are using now prosumers. Consumer plus producer. Means producer plus consumer. Prosumer. Whoever is building the new home, whoever is building the new institute, they have to follow the policies like generate this much energy by your own to sustain or to just increase the rate of renewable implementation. And we have faced so much difficulties. Now is the era of AI. We have so much difficulties. Whatever difficulty we have, give it to AI. AI will solve. That is our now habit. Whenever we are now less habituated with the finding some answers from book, we are directly writing in the. Yes, we'll talk about that. So everyone is writing on the chat GPT, whatever answers they are getting, no need of searching books. So those are the solutions, but AI cannot do everything. Just an example, suppose I am showing some dog picture. So how AI works? AI works with the training list. Something will take a lot of things and then assume what can be the solution. So suppose these questions we are citing. So now tell what the dog is doing. This is if this much data is given as an input. Dog is sitting. I will tell dog is sitting. Now I am giving this picture. Then I may respond. Dog is lying down because head is on the food. Now I am giving another picture. Dog is standing. But originally, what the dog is doing? So you have to give every data to follow the complex situations. Then only you will get the proper answer, which is difficult. You will miss some of the scenarios whenever the system will become complex. So you cannot rely on the AI completely. So now I'm just concluding. So renewable energy sources are changing the landscape worldwide. We have seen in the presentation. It will give the benefits in the environmental perspective, economic or social thing. But why we are not going just sudden change in the renewable scenario? Without proper preparation, we cannot go. We all know the story of Sri Lankan farming transition. Someone gave the idea to the government that use of pesticides is creating the issue. It is harmful for your body. Then they forcefully stopped the use of pesticides without much preparation. Then suddenly the production levels went down and they found the situation. So without proper preparation, you cannot go for the solutions. So we need proper thing. We need to know the reasons behind every challenges, and we need to find the proper technologies. So our group is also working in the similar domain, like renewable integration challenges and finding the solutions, but not in this basic science. So some abnormalities, you may say, in general cause, like faults we are getting. So faults are like disease in the human body. How to diagnose the disease? So now the human body composition also changing. So it is getting difficult to detect some diseases. Similarly, in our lead also some abnormality. What could be detected easily earlier because of this renewable things, because of the inverter behavior, unpredictable behavior, it is getting difficult. So we are finding the solutions there. I am not discussing because of the time limited in this perspective. We have several collaborations on these areas. Okay. Now, before final concluding things, yes, we need renewables, but we should take proper precautions. Government have started so many programs, but it is something people are thinking not to progress in that space. But you should motivate others that it is needed. Of course, you cannot stop the integration of renewable sources, but parallelly you should develop, you should proper solutions to the challenges being faced through the renewables. Thank you.
Thank you. If somebody from the participants wants to ask or interact with the speaker, please come up.
What is the efficiency of conversion of solar energy available in market?
Available
in market, commercially available.
It depends on
Conversion efficiency.
Conversion efficiency is very low, we can say. That is, sometimes it is around 40%, 37%, like that. Sometimes it is, we have reached with special technologies 80% also. But it depends upon the availability of the materials what we are using. But everything is not available in the things. We have seen efficiency. Now the thing is that we cannot say in terms of efficiency in just a word that efficiency thing. Efficiency with perspective to what? Because you have to consider so many factors. How much land you are acquiring for these things, and what
Commercially available in the market.
yes.
So that we can use.
See, exact data I cannot remember.
It is 14%, but it was around a few years back.
Okay. See, that data I cannot remember currently right now. But the thing is that efficiency, we generally think about the whatever the input expenses we are doing and whatever the output we are getting. But whatever the existing electricity thermal point of view, those are influenced by the policies, subsidies. So if you include the subsidies, then efficiency you can find in different way, and if you exclude the subsidies, you will get different ways.
Okay, thank you, Dr. Sujit Kaladi, and keep doing good work to accelerate transition to renewable energy. All the best. The next resource person of this session, Professor Santosh Kumar sir, he is the professor in the Department of Physics, Commerce College, College of Commerce, Arts and Science, Patna. So, a brief introduction of Professor Santosh. Yeah, it's a very brief introduction. As far as I know, he has a very vast introduction. Anyway, it gives me a great pleasure to introduce Professor Santosh Kumar, Professor of Physics at College of Commerce, Arts, Science and Patliputra University, Patna. Dr. Kumar's research interests lie in the field of material science with a special focus on functional metallic oxides. Beyond his research, Dr. Santosh Kumar has been deeply involved in popularizing science education and promoting concept-oriented physics teaching and learning at school and college levels. Working closely with the Padma Shri Professor H.C. Verma, retired Professor of Physics, IIT Kanpur, he has also served as a co-instructor in MOOC course learning physics through simple experiments conducted on IIT Kanpur platform. His research collaboration extended to UGC DAE Consortium for Scientific Research in Indore, and he has published extensively in the reputed international journals from Elsevier, Springer, and IOP. Dr. Kumar has contributed chapters in solid-state physics for Nalanda Open University curriculum. His engaging lecture on popular YouTube channel Distinct Physics continue to inspire and guide BSc, UG and PG students across the country. Sir, we are very grateful to have you on this session. He will be delivering his lecture today on the effect of iron doping on structural, optoelectric and magnetic properties of zinc oxide synthesized by chemical co-precipitation method.
Thank you, madam, for the kind introduction. First of all, I express my sincere gratitude to T.P.S. College family for giving me this opportunity to be here and speak something on this topic that is a different story altogether. But this is a great privilege for me to speak something in the chairmanship of Professor Tripti Gangawarji. I have great respect for her for many reasons. And another opportunity is that my revered teacher, Professor Advani Prasad Sinha ji, who is going to be the chief guest of the valedictory function of this seminar, today's seminar, is sitting before me. So this is an added advantage for me. And before I start speaking something on this topic, I would like to tell that today I requested sir, I think at around 10 a.m. and you will be surprised to know that he has not still got any invitation from the organizers. I requested sir on behalf of organizers that if you become the chief guest of this 2 days international seminar, this will be an honor for me at least. And he happily agreed and told that this will be an honor for me as well. And this is in itself appreciable that a small college like T.P.S. college is at least daring
to organize such an international seminar despite several constraints. So I express my sincere gratitude to respected sir to be here. Thank you, sir, for honoring my words. And I wonder that if all the academicians of Bihar at least takes this kind of taste, then the scenario will be something different. I was chairing one session yesterday, and I was requesting all the speakers to kindly speak in Hindi. So now onwards, I would like to speak in Hindi. हम लोग जो लोग यहाँ पर थोड़ा सा फिजिक्स केमिस्ट्री में काम करते हैं उनको पता है कि इस दुनिया में, सिर्फ भारत में नहीं, इस पूरे दुनिया के अंदर में जेडेनो वाइडली स्टडीड सिस्टम है। इससे ज़्यादा किसी सिस्टम का शायद स्टडी नहीं हुआ है। बट इन स्पाइट ऑफ दैट, जितने भी आप रिसर्च पेपर्स पढ़ेंगे वो यही लिखते हैं कि स्टिल अभी नाइव स्टेट में, और बहुत सारी इसकी मिस्ट्रीज हम लोग अभी तक समझ नहीं पाए हैं। चाहे इसके मैग्नेटाइजेशन से रिलेटेड प्रॉपर्टीज हों, सबसे ज़्यादा स्टडी हुआ है जेडेनो में मैग्नेटाइजेशन इंड्यूस करने को लेकर के, और इस बात को समझने को लेकर के कि इसमें मैग्नेटाइजेशन आ कैसे रही है। लेकिन हर लोग अपने अपने तरह के क्लेम्स कर रहे हैं। उन्होंने जो भी काम किया उसके हिसाब से जिस तरह का मैग्नेटिक सिग्नेचर उनको मिला उसको अपने हिसाब से एक्सप्लेन करने की कोशिश की, और तमाम तरह के जो इंटरैक्शंस हैं, किसी ने कहा कि इसमें सुपर एक्सचेंज हो रहा है, किसी ने कहा इसमें RKKY हो रहा है, किसी ने कहा बाउंड मैग्नेटिक पोलेरॉन हो रहा है, फलाना ढिमाका करते गए, और अंत में सब लोग कहते हैं कि इट इज स्टिल टू बी अंडरस्टूड। तो इसीलिए इतना वाइडली स्टडीड होने के बाद भी हम लोग इसका स्टडी कर रहे हैं और रोज इस पर पेपर्स छप रही है। हम लोग यहाँ पर कॉलेज ऑफ कॉमर्स आर्ट्स एंड साइंस में जिस तरह का कंस्ट्रेंट T.P.S कॉलेज के पास है, मोटा मोटी वैसा ही कंस्ट्रेंट हमारे पास भी है, बट उसके बावजूद थोड़ा बहुत हम लोग काम करते हैं। अभी कम्युनिकेटेड एक पेपर है हमारे स्टूडेंट का, धीरज कुमार बैठे हुए हैं, उन्हीं का वर्क मैं उनके परमिशन से यहाँ पर ये कर रहा हूँ। ये एथिकल राइट मेरा नहीं है, विदाउट हिज परमिशन आई कैन नॉट डिलीवर हिज वर्क एट लिस्ट। अनपब्लिश्ड है, इसलिए मैंने बहुत कुछ डिस्क्लोज इसके अंदर में नहीं किया है। कुछ मैं आपको तस्वीरें दिखाऊंगा और आगे बढ़ूंगा, लेकिन इसके पहले की कहानी पूरी कहूंगा। तो जेडेनो, जैसा कि हम सब लोग जानते हैं कि एक डायामैग्नेटिक सिस्टम है, और डायामैग्नेटिज्म इसके अंदर में जो आती है सेमीकंडक्टिंग प्रॉपर्टी है, 2,6 सेमीकंडक्टर है, और अगर वैलेंसी के हिसाब से देखिए तो 2 + 6 8/2, अगर एवरेज निकालिएगा तो 4 होगा, जो आमतौर पर हम लोग कहते हैं कि फॉर ए सिस्टम टू बी सेमीकंडक्टिंग इट्स वैलेंसी शुड बी 4। लेकिन अभी जितने भी अपनी इलेक्ट्रॉनिक इंडस्ट्री है वो मिनिएचराइजेशन की तरफ जा रहा है। इसमें सर जब हमारी उम्र में रहे होंगे तो पता नहीं कितना बड़ा ट्रांजिस्टर यूज किए होंगे, और आज एक छोटे से चिप के अंदर में हम लोग कितना ज़्यादा स्टोरेज कर रहे हैं, अनइमेजिनेबल। तो इनलिमिटेबल प्रोग्रेस हुआ है इलेक्ट्रॉनिक इंडस्ट्री के अंदर में, और हम लोग मिनिएचराइज करते चले गए। और आज एक छोटे से मोबाइल के अंदर में जितना बड़ा स्पेस हमें मिलता है, जब पहली दफ़ा इसमें से बहुत सारे लोग कंप्यूटर खरीदे होंगे तो उसमें उतना स्पेस नहीं होगा जो आज आपके बहुत साधारण मोबाइल में मिल रहा है। तो इस मिनिएचराइजेशन ने, जब कोई भी इन्वेंशन होती है, कोई भी काम हम लोग करते हैं, तो वो एक नया प्लेटफॉर्म भी देता है सोचने के लिए। जब हम मिनिएचराइज करते चले गए तो एक स्टेज ऐसा आता है कि हम इतना ज़्यादा मिनिएचराइजेशन कर देंगे कि क्वांटम इफेक्ट्स विल कम इनटू प्ले। तो अभी तक की जो सेमीकंडक्टिंग इंडस्ट्री चल रही थी उसमें हम इलेक्ट्रॉन्स के चार्ज डिग्री ऑफ फ्रीडम का इस्तेमाल कर रहे थे। इलेक्ट्रॉन के चार्ज को इलेक्ट्रिक फील्ड अप्लाई किया, इलेक्ट्रॉन को फ्लो करवाया, उससे करंट लिया, उसके चार्ज डिग्री ऑफ फ्रीडम का इस्तेमाल किया। लेकिन जब हम मिनिएचराइजेशन की उस स्टेज में चले जाएंगे जहां पर क्वांटम इफेक्ट्स काम करना शुरू करेगा, तो शायद क्लासिकल इलेक्ट्रोडायनेमिक्स हमारा काम नहीं करने वाला है, और तब उसके क्वांटम प्रॉपर्टीज का हमें इस्तेमाल करना पड़ेगा और उसके स्पिन को भी एक्सप्लॉइट करना पड़ेगा। तो जो डाइल्यूट मैग्नेटिक सेमीकंडक्टिंग सिस्टम की बात हम लोग करते हैं, उसमें नाम से ही आपको क्लियर है, डाइल्यूट मैग्नेटिक सेमीकंडक्टिंग सिस्टम्स। सिस्टम इज बेसिकली सेमीकंडक्टिंग, उसमें हम लोग कुछ डाइल्यूट डोपिंग वगैरह करके और मैग्नेटाइजेशन इंड्यूस करने की कोशिश करते हैं। और डाइल्यूट डोपिंग इसलिए करते हैं कि वो अपनी सेमी कंडक्टिंग प्रॉपर्टी का लॉस न करे, सेमी कंडक्टिंग प्रॉपर्टी को रिटेन करके रखे और उसमें मैग्नेटाइजेशन इंट्रोड्यूस हो जाए। तो हम लोगों ने वही किया है, ZNO के अंदर में आयरन की डोपिंग किया है। और कल जो बात चल रही थी शुरू के 3 टॉक्स में, जिसमें हमने कंक्लूडिंग रिमार्क्स भी दिया था, जिसमें डॉक्टर मनोरंजन कर जो हमारे रजनीश कुमार के सुपरवाइजर हैं, उन्होंने कह दिया था कि ये 10% सॉल्युबिलिटी है और उस पर एक क्वेश्चन उठा था। तो उसमें हमने इस पेपर में ये भी कुछ बात किया है कि जो प्रोसेस पैरामीटर्स होते हैं मटेरियल सिंथेसिस के, वो इस चीज को कंट्रोल करता है कि स्ट्रक्चरल इवोल्यूशन कैसा होने जा रहा है और उसकी सॉल्युबिलिटी उसके अंदर में कितनी होनी जा रही है। जो सेकेंड वाला टॉक था जिसमें कि उन्होंने कुछ फेज डायग्राम वगैरह बना करके और वो लिमिट तय करने की कोशिश किया था। तो इसमें वही सारी कहानियां हैं कि अभी हम लोग उसके चार्ज डिग्री ऑफ फ्रीडम का इस्तेमाल कर रहे हैं, लेकिन अगर हम स्पिन का इस्तेमाल करंट के फ्लो में लेना करना शुरू कर दें तो स्टोरेज डिवाइसेस के अंदर में हम इसका इस्तेमाल कर सकते हैं, क्योंकि स्पिन विल बी कंट्रोल्ड बाय मैग्नेटिक फील्ड एंड चार्ज डिग्री ऑफ फ्रीडम विल बी कंट्रोल्ड बाय इलेक्ट्रिक फील्ड। तो हम इलेक्ट्रिक फील्ड और मैग्नेटिक फील्ड दोनों का इस्तेमाल करके एक ऐसा कंट्रोलेबल सिस्टम बना सकते हैं जिसमें हम एक साथ दोनों काम कर सकते हैं और स्टोरेज कैपेसिटी काफी बढ़ा सकते हैं। तो इसमें करते यही हैं, एक पिक्चर के माध्यम से मैंने समझाने की कोशिश किया है कि एक मैग्नेटिक मटेरियल जिसको कहते हैं, थोड़ा सा 11-12 के स्तर में भी जो लोग थोड़ा सा मैग्नेटाइजेशन पढ़े हैं उनको पता है कि जिसको आप मैग्नेटिक मटेरियल कहते हैं उसमें आपके स्पिन सारे एलाइन हैं, पैरेलल एलाइन हैं। तो वो फेरोमैग्नेटिक प्रॉपर्टी एक डोमेन के अंदर में बना रहा है। और डीएमएस और नॉन मैग्नेटिक, सबसे राइट वाला जो है वो नॉन मैग्नेटिक सिस्टम है, और उसमें हमने क्या किया है कि ट्रांजिशन मेटल अगर कहीं कहीं पर डोप कर दी तो ट्रांजिशन मेटल के अंदर में आपका अनपैरेलल मतलब अनकपल्ड स्पिन रहने वाला है, जिसके वजह से कहीं कहीं पर वो मैग्नेटिक एलिमेंट के रूप में डोप्ड है और वो डाइल्यूट डोपिंग है, कुछ यहाँ है, कुछ वहाँ है, कुछ वहाँ है, कुछ वहाँ है। वो शुरू में एक दूसरे को देख नहीं रहे, शुरू में एक दूसरे के साथ इंटरैक्ट नहीं कर रहे हैं, लेकिन अब उसके बहुत सारे तरीके हो सकते हैं। कंडक्शन बैंड का कोई इलेक्ट्रॉन है, उसको वो देखेगा, फिर वो दूसरे को देखेगा, तो जिसको कहते हैं कि इटिनरेंट इलेक्ट्रॉन के थ्रू वो कम्युनिकेट करना शुरू कर दिया और फिर आपस में कम्युनिकेशन बना दिया, और ये उसको अलाइन कर दिया, वो उसको अलाइन कर दिया, वो उसको अलाइन कर दिया, और ऐसा करके उनके स्पिन्स पैरेलली अलाइन हो गए और थोड़ा सा मैग्नेटिज्म उसके अंदर में इंड्यूस हो गया। ये बेसिक प्रिंसिपल है किसी भी डाइल्यूट मैग्नेटिक सेमीकंडक्टिंग सिस्टम का। हम लोगों ने यहाँ पर ZNO